Okay, welcome to the Spur Gear tutorial for Gearotic motion. We're just going to take a look at the Spur gears and the various settings that you can make in order to create them. When you're running Gearotic motion, just click on the Spur Gear tab. That'll take us to a screen which shows us our gears. Again, as in the other systems, the gear on the left is considered to be the master gear. The gear on the right is considered to be the slave gear. These are arbitrary designations, just simply so you know which button you're pressing when it's add master or add slave to project. When you're on the screen, you can simulate and spin the gears, as well as zoom in to see how a mesh occurs. Zooming is done with the mouse wheel. When you're on the screen, and you can pan by holding both the left and right mouse key and moving your screen around. Double clicking on the screen will take you back to normal. On the screen at the same time as the gears, you will see some red markers, which is basically just showing you the actual width of the gears themselves, and a third set of red markers which show us the distance between the shafts. On the screen in white lettering is your gear diameters, your pitch diameter, base, root, addendum, dedendum, tooth thickness, and two new settings: maximum mill diameter and minimum fourth axis length. The maximum mill diameter is the maximum diameter end mill which will actually fit between the roots of the teeth in order to cut them. The minimum fourth axis length is the minimum length that you will have to have on the cutting area of a milling bit in order to cut these spurs on a fourth axis. Spurs can be cut on a 2.5 axes, which is the preferred method of doing them. However, to get a very wide gear, a thick gear, you often need to cut them on a fourth axis. And in that case, you will need a bit, in this case, 8.3 millimeters long at a minimum. So we have our gears. We can set them. They're module up here at the top left-hand corner where it says module. Pressure angle, which is defaulted to 20, is a pretty standard pressure angle for gears these days. You don't really need to change the pressure angle usually, although the module you'll need to change in order to dictate the size of the gear. There's a checkbox for metric, which changes us from metric to diametric pitch mode. When you click the metric checkbox, it will affect all of the types of gears in the program. So always check your metric box prior to designing a gear to make sure you're in the proper mode. We have a checkbox for cycloidic teeth. If we check it, you can see that you go to the older style of cycloidic teeth. These are commonly used in clockworks. At the moment, the only cycloidics that you can generate are the standard module cycloidics. The parameters underneath these checkboxes, which change things such as the profile shift, stubbing, and tooth width, are not used in epicycloidic teeth. The size of an epicycloidic tooth is dictated by the typical module settings of your spur gear. The root depth and so on is a mathematical result of the distance from the pitch line or the baseline to the tip of a gear. So there's not much that you can do to change a cycloidic at this point. There is some discussion underway to move them to their own tab, however, to allow for modification. I'll uncheck that. We'll go back to standard gears. The next two boxes are pretty standard. 22 teeth and 15 teeth is it's currently set for the gears that are on the screen. You can change these and the gears will dynamically shift to the new settings. You can see I just changed one to 18 teeth. The next 6 settings, 3 for each gear, are profile shift, stubbing, and width. If you don't know what these do, I highly recommend you not use them. They're not needed by most people. You have to be something of a gear expert to understand what's going on with the shift, stubbing, and width. And chances are very high that if you need to know how to use these boxes, you already do. If you are changing the shift, stubbing, and width, and you're wondering what the hell you screwed up and how do I get back to normal, you can press the reset button, which will bring those 6 settings back to a standard spur gear definition. Underneath that, we also have a checkbox called internal gear. This will change the master gear into an internal gear, and you can see on the screen now we have an internal ring with a small pinion inside of it. More can be said about internal gears, and we'll deal with that later on. Beneath that, we have a shaft diameter. That's pretty self-explanatory. It's simply the diameter of the shaft, which is in the center of each of the gears. These shaft holes only really show up in terms of milling the gear in 2.5D, in which case we'll cut out that hole during the G-code process. They're also put out as the size of a hole in your side, front, and top and bottom plates. DXFs are put out for those plates by the output manager when you generate your gear profiles. Regen button regens the gears to make sure that they are indeed shown on the screen with the specifications that you have set. Normally you won't have to press this, as the gears do regenerate when you change an important setting. Underneath that is a displays control. We can turn on the base circle, the root circle, the tip circle, and the pitch circle, simply as a tutorial to show what these parameters are used for in a gear. The base circle, for example, is the starting point of an involute curve. So each of the involute curves on the teeth are basically unwound off of this base circle. And if a person's interested in investigating the gears, they could turn on the base circle, for example, and begin to change profile shift and stubbing to see what effect those parameters have on a base circle. Again, other than educational purposes, is really not much use to you, and you can pretty much leave them alone. Spoke control allows us to turn spokes on or off. Here you can see spokes without, or gears without spokes. Turn them on and we have a selection for type of gears. You can have curved gears such as the one shown on the screen, or we can go to a standard gear which gives us straight spokes. The spoking manager will be changed at some point in the future. I've got quite a few requests for a proper marking out system to better deal with the spoking on the gears. At the moment though, you're only permitted those two selections. Along with that is leg ratio, rim ratio, and the number of spokes. These are not standard specifications for gears. Normally you would specify your spokes by how thick you want your rim to be and so on. But we've tried as hard as we can to make Gearotic as easy to use as possible. So rather than enter a situation where a person changes the number of teeth or the module of a gear and then is left with spokes which are far too small for that gear, we've gone with percentages in order to create a spoke with parametrically follows the size of the gear being created. This isn't optimal for a lot of users though, and as I say, the new spoking manager to come at some time in the future will address those concerns. We also have a library button which when pressed allows us to store any of the screen parameters that are currently displayed into a setup. This is used for such things as creating timing pulley gears. You can, through modification of the shift, stubbing width, and other parameters, make a gear that closely resembles a timing gear or a pulley belt gear. When you do so, rather than try to find those settings again, you would use the library to save a library profile. Loading one of these profiles will instantly change all the settings on the screen and reproduce those gears that you've saved. We won't worry about that too much for now. Other than that, we have two other buttons on the screen that are probably the most important. We have an Add Master to Project and Add Slave to Project. If you've been listening or you've watched the other tutorials, you realize by now that the one on the left is the master, the one on the right is the slave. Keep that in mind because it does get important on some gear type selections. So as an example, let's add a master to the screen. When we do so, we come up with our Create Solid Gear dialog. This is the standard Spur creation dialog and allows us to further modify the type of gear that we're going to place on the screen. When we do this, the top box is gear name. You can enter any name you wish for the gear. However, the program, in order not to have gears of the same name, will automatically fill in this box with an involute or helical or bevel as the name of the gear, and follow that up with a suffix of the number of the gear. If it's the 14th gear you've created, for example, it could come up and say bevel number 14. The database is organized by the gear name, so it will not allow you to name two gears the same. Thickness of the gear is just that, the actual thickness of the gear going from the front to the back. You can see mine is defaulted to 12.5 millimeters, for example, this being a half an inch and exactly the size of the plywood I typically use to cut gears from. The system will remember this setting. Each time that you set it and say OK to this dialog, that number will be changed. So if you're frequently changing the thickness of your gears, you might want to check that each time. If we don't push anything else on the screen and we simply hit the OK button, we'll end up with a Spur gear on the screen. built as specified on the screen that we created. And as you can see, we now have a gear screen. I can rotate this gear by pushing the middle mouse button, or as of version 2.0, I can hold the Shift and Control key at the same time as my left mouse button and rotate the gears. This latest change is to facilitate the use of laptops, which oftentimes do not have a center mouse button wheel. Both mouse buttons at the same time, left and right, allow us to pan a gear around the screen. So let's go back to the Spur creation and add a slave to this. And we'll just hit OK because we're not interested in any other type of gear at the moment than the Spur gear itself. We now have a screen, and if you've watched the project video, you know that if the gear is blue, we're going to place the gear on the outside of this primary master. And if we point to the center of the gear, it'll turn pinkish, and that tells us we're going to place the gear on a shaft. Should we choose to place it on the gear, we can rotate the gear around and stick it in a point in space. The screen then switches to an ISO screen view, and again you can rotate it around and go from there. Let's delete these and go back to another type of gear. Right-clicking on the top of the project screen gives us a menu which allows us to delete all mechanisms. We'll get a warning, say yes, and they're gone. Back to the Spur screen. Let's take a look at another type of gear. If we hit Add Master to Project and we accept our first helical option, check the helical box, and we're asked which helical angle we would like to use. Helical angles can go from 0 to 45 degrees and are specified as left or right-handed. If you don't select left-handed, you are obviously right-handed. In this case, let's just select a 45-degree helical and leave the left-hand box unchecked, which gives us a 45-degree right-handed helical. And there we have it on the screen. You can see that the thickness of the gear is actually the 12.5 millimeters I had set previously. If you're in question as to what thickness or what parameters you used, just go up to the project tree, click on the gear, and you'll be provided a lot of information on the screen telling you exactly what's going on with that gear. In this case, on the right hand side, we'll see the gear thickness is 12.5. Now let's go back to the Spur screen and create another helical. I'm going to say add slave, although with helicals I could just as easily say add master. Helicals don't care what a master or slave, they're not matched that way. So let's select helical, and let's select another 45-degree helical, and I'm going to select left-handed. If two helicals are meshed, one right-handed and one left-handed, they will sit on an axial plane. So we'll roll this helical around and stick it on, and by clicking we'll set its location, and you can see now I have two gears on the same axial plane. They mesh well, and they will run together when simulated. That's not always the case with helicals, or not always the case that someone wants to do that with a helical. Let's take a look at add another helical to this project. We'll go helical, 45 degrees, and this time I won't check the left-handed box. This is to tell it that now I have two right-handed helicals that are going to mesh. The system will take this information, and when we roll our gear around and place it, you'll notice that one gear is now sitting 90 degrees opposed to the other in a transaxial plane. This is because if you use two helicals of the same handedness, they will rotate to a shaft angle which is equal to the sum of the two helicals. Since both of these gears were 45-degree helicals, they create a 90-degree shaft offset. And you can play with the helicals all you like. You'll find that they always point in the direction of the two angles added together. So let's erase these and take a quick look at the next type of gear that we have. Go back to the Spur gears. We'll add a master, and then we'll select a bevel gear. Now bevels come in three flavors. We can have a straight bevel, a helical bevel, or a zero bevel. Zerols are close to knuckle gear in their capabilities and their reason for existence. We also have a left and right-handed selection. Unlike helicals, bevels cannot be placed meshing together if they're both of the same handedness unless they are straight. Straight bevels by definition do not have a handedness, so that it won't matter. But if you select helical or zero, you better remember which handed your master and slave are, because it's important that they always be opposite hands. So let's select, for the sake of argument, a straight bevel. 90-degree shaft angle. One change comes into effect at this point. The gear thickness at the top of the screen no longer reflects the actual thickness of the gear. It now reflects the face width of the gear. Face width of the gear is the distance of the thickness of the teeth measured from the outside to the inside. This means it has a sinusoidal relationship to the actual thickness of the gear. So by specifying a 12.5 millimeter thickness, I may be specifying as little as 5 millimeters thickness for the gear, depending on the conical angle of the bevel. If all this sounds like jabberdy nonsense to you, good, ignore it. It's really not that important to you. Suffice it to say that when you select a bevel gear, the system will compute the length of that gear to its apex of its cone. It will take 25% of the value and try to assign that to the thickness of the face width. If the thickness of the gear is set less, it will take the thickness of the gear that you've set. So in this case, we're asking for a bevel gear, straight, 90-degree shaft angle, with a 12.5 millimeter face width. Say select, and we'll end up with a master on the screen showing us that gear. Now this might make it a bit clearer. This gear, if we look at it from the left, we can see that it is not 12.5 millimeters wide. If you watch where your mouse coordinates are at the top of the screen, you can see at the moment I'm at a Z of 8.4, and when I get to the back of the teeth, I'm at about minus 12. That's about 16 millimeters thick in total. What is 12.5 millimeters here is the distance of one of these teeth from the point of the mouse that's pointing now to the point of the mouse where it's pointing now. This isn't terribly important to you. You can simply place them quickly. It affects the tooth strength. Normally you want to have a tooth which is thick enough to handle the torque that you're going to place on a bevel gear. Again, if you understand the issue of the strength or the torque of the teeth, then you probably already realize that the face width is important. So the setting of that gear thickness should become somewhat clear to you. Now let's pick a slave to put onto that gear. Let's go to the slave of the project, select bevel, and we want a straight gear, but we do want to check left-handed. As I said earlier, a left-handed bevel is needed when mashing with a right-handed bevel. And we will say OK. System will allow us to click the gear to place it, and you can see it always rolls on the outside, which is not the way a bevel moves, but this is to ease in placing. So if we were to place this at 90 degrees and click, the system will rotate the gear down into place to create a proper bevel combination. One of the most common problems that I've seen reported so far, and the reporting time is short, mind you, is that people don't understand that when it comes to bevels, masters must be placed with slaves. Placing two masters together is not a good thing. They will not mesh properly. When we design bevels, we design them to be master and slave. This is because the number of teeth on the slave versus the number of teeth on the master influences the conical angles, which are very important to the generation of these gears. So if I try to add a master bevel to this gear, we'll get a result which looks like the following. And as you can see, they are not meshed together. They don't look as if they're going to work at all, and indeed they won't. In future versions of the software, we'll make it illegal to place two masters together such as this, and we won't have to worry about that mismatch anymore. This is not to say that you can't have multiple gears on a bevel, but it would have to be multiple pinions on a wheel or multiple wheels on a pinion. You cannot change any parameter of a spur gear or a bevel in order to create a bevel gear. Once you change any of the parameters of either of the gears, both gears must be regenerated, and you must use the new gear design. You can't stick with what you had on the screen for that previous gear. I think that's just about it for a quick review of how to generate spur gears. Hopefully you'll have some fun in their generation. There will be further videos on how to put the gears into orientations such as planetary gears and so on. Thanks for watching.